do a couple of examples involving the total differential. So starting with the first example, which is just asking us to find the total differential for the function z equals e to the minus x tangent of y. So let's remember that dz is going to be del z del x dx plus del z del y dy. So in order to find the total differential, I just need to find these partial derivatives. So the partial derivative of z with respect to x, remember I'm going to treat anything with y, any function of y, as a constant. So I'm going to say tangent of y is just a constant. And I take the derivative of the function of x, e to the minus x. So that's times minus e to the minus x. So that's minus e to the minus x tangent of y. And then I'll find del z del y. So now I'm going to treat any function involving x as a constant and take the derivative with respect to y. So e to the minus x, we're treating it as a constant, and the derivative is secant squared y. The derivative of tangent, of course, is secant squared. So this is e to the minus x secant squared of y. Then to answer my question, I get to say then dz, the total differential, is equal to del z del x, which is minus e to the minus x tangent of y, dz, plus del z del y, which is e to the minus x secant squared of y, dy. And that answers my question. All right, let's look at another example. We have the function w equal to 5x plus y all over 6z minus 4y. So in this case, our total differential will be dw, and that should be equal to del w del x dx plus del w del y dy plus del w del z dz. So again, we'll start by finding our partial derivatives. We're taking the derivative first with respect to x, so del w del x, and we're going to treat y's and z's as constants. So this just ends up being 5 times x, the derivative is 5. Y is a constant, so its derivative is 0. And on the bottom we have 6z minus 4y, because that constant was multiplied with the 5x. Next I'll find del w del y. So now I'm going to treat x and z as constants. Since I have y on both the top and the bottom, this is going to require the quotient rule. So we'll do the quotient rule. That tells us we have the bottom, 6z minus 4y, times the derivative of the top, and the partial derivative of the top with respect to y is just 1, because again, the 5x term is a constant, its derivative is 0. Then we subtract the top, 5x plus y, times the derivative of the bottom. The derivative of the bottom is negative 4. And all of that will be over the square of the bottom. So 6z minus 4y whole squared. So let's clean that up a little bit. That should be 6z on top. I have minus 4y from the first term, and it looks like plus 4y in the second one, so that will cancel. And then I have minus 5x. So 6z minus 5x. And I apologize, that minus 5 should also be multiplied by minus 4. So that's going to be a positive 20x. 6z plus 20x over 6z minus 4y whole squared. That's going to be my partial derivative with respect to y. Then I'll find my partial derivative with respect to z, del w, del z. And in this case, we're going to be treating x's and y's like constants. So this can be like 6z minus 4y to the negative 1 times 5x plus y. So we're going to have minus 6z minus 4y to the negative 2. And then we're going to multiply by 5x plus y and the derivative of the inside, which is 6. Now moving this back to the bottom, my fraction is going to be over 6z minus 4y squared. And on top, I have 30x plus 6y, and the whole thing is negative. So I have all of my partial derivatives. Now I just need to put them together. My total derivative then, dw, is going to be the partial with respect to x. So let's go back and look. That was 5 over 6z minus 4y. So that's del z del y, del w del y times dz. I'm sorry, that's del w del x times dx. Then I want to add del w del y times dy. So that's 6z plus 20x over 6z minus 4y squared. So del w del y times dy. And lastly, want to add del w del z dz. So that's actually going to be minus 30x plus 6y divided by 6z minus 4y whole squared dz. This is my total differential.